In 9.8, we're going to be looking at the power series. So we were looking at series in general in the last couple sections before 9.7. And here is expressly what's called a power series. This represents a polynomial that goes on forever. That's a series. Notice if we put a 0 in, we get -1 to the 0 power, which is 1, x to the 0, which is 1, over 4 to the 0, which is 1. Then when we put in a 1, we're going to get negative x over 4, and then we're going to get x squared over 16, and then x cubed over 64, and so forth. And that goes on forever. So for certain values of x, this will converge. For certain values of x, this will diverge. So we want to find out, um, this one asks specifically for the radius of convergence, meaning if we look on the number line at x values, how wide of an interval are we going to have um, that converges? We'll go a step farther and we'll find the actual interval of convergence here as well. So what we're going to do is we're going to use the ratio test. And instead of calling it a sub n, since this is a function, let's call it u sub n. And that's going to be x to the n over 4 to the n. Remember in the ratio test, we do the absolute value of u to the n plus 1 over u to the n, or in the past we've had a, same difference. And that converges as long as the absolute value of that ratio is less than 1. Since we're taking the absolute value, I'm going to drop the -1 to the n when we're listing our u sub n. So u sub n plus 1 comes from everywhere we have an n, replace it with n plus 1, like so. So we're going to take the limit as n goes to infinity of x to the n plus 1 over 4 to the n plus 1 divided by that. And when we divide by that, we multiply by the reciprocal. So 4 to the n over x to the n. And we want to find out when is that less than 1. So let's rewrite a little bit. When we have an exponent that has adding in it, we can rewrite that as x to the n times x to the first. Same thing on bottom. We can call that 4 to the n times 4 to the first. And then we're going to be able to reduce that. The x to the n and the x to the n cancel. 4 to the n and 4 to the n cancel. So to find out when that's less than 1, if we let n go to infinity, notice there are no n's left in the parentheses. So if n goes to infinity, we're left with the absolute value of x to the first over 4. In terms of the variable for our limit, x is a constant. So if we let n go to infinity, we're left with everything that's not an n. So this will be when our series converges. Every x value that's described here, for every x value that's described here, this series will be convergent. On the other hand, for every x that's not in this description, if we replace x with those numbers, then this series will be divergent. So we can get x by itself. We can multiply both sides by 4 to make the fraction go away. The absolute value of 4 is 4, so those cancel. We're left with the absolute value of x is less than 4. Now, generically, if we have an absolute value of x minus c is less than r, the number that we subtract from c tells us where our interval is centered. The number on the other side is going to give us our radius of that interval. So for example, if we have x minus 3 is less than 2, just for illustration, I'm going to use an equal here, but notice we don't have an equal. This interval is centered at 3, and it goes to the right 2 and to the left 2. And it includes everything in between there. Notice if we put a 5 in, 5 minus 3 is 2. The absolute value of that is 2. If we put in a 1, 1 minus 3 is negative 2. That absolute value is 2. Less than, so it's everything in between. So if we didn't have the equal sign there, the only difference would be we'd have parentheses there instead of brackets. So when we write an absolute value in this format, again, the number here is the center, the number here is the radius. So ours has a radius of 4, and if nothing is being added or subtracted to the x, then our center is at 0. So our power series converges as long as x is between negative 4 and 4. If x is between negative 4 and 4, then our power series converges. Now, if we went back and looked at how the ratio test worked, it converges if the ratio is less than 1. It diverges if the ratio is greater than 1, but if it equals 1, then we don't know exactly what it does. The boundaries here are where we would be equal. So the test fails at negative 4 and 4. What does that mean? That means we need to substitute 4 into our series and check when x is 4, is that series that we end up with going to converge or diverge? And then we would do the same thing at negative 4. So even though this is not part of the question, let's do this one to illustrate. So we have the series, I believe it's 0 to infinity, negative 1 to the n, x to the n over 4 to the n. Let's see if that's right. Okay. So that's our power series. So to check and see if 4 is included, we put a 4 in where we have an x. And we check to see if that one's going to converge or diverge. Well, notice 4 to the n over 4 to the n, that reduces. So we have the series negative 1 to the n power. What does that do? That goes 1, negative 1, 1, negative 1, 1, negative 1. That bounces back and forth between different values. If we only look at the first sum, the first term, we get 1. If we add the first 2, we get 0. If we add the first 3, we get 1. The first 4, we get 0. So our sums are bouncing back and forth between 0 and 1 forever. That's not going to anything, so that's diverging, divergent. So 4 is not included. Hence, we are going to have a parenthesis at 4. Now we need to do the same thing and check negative 4. Can x equal negative 4? So we take our power series, and where we have an x, we replace it with negative 4. We can simplify this a little bit. We can do this several different ways. The negative 4 and the 4, we can pull the exponent out, and we can put negative 4 over 4 there. Negative 4 over 4, that reduces to negative 1. So that's the sum from n equals 0 to infinity of negative 1 to the n times negative 1 to the n. Notice we have the same base, so if we have the same base, we add the exponents. N plus n is 2n. Well, 2n, that's going to be even. Anytime we double a number, we get an even value. If we raise a negative number to an even power, it's always going to be positive. So when we put a 0 in, we get 1. When we put a 1 in, we get an exponent of 2, so that's 1. And then 1, and 1, and 1. Well, that's going to go to infinity. That's going to add 1 forever and ever. So again, that's going to diverge. So negative 4 is not included either. So if we were asked, what is the interval of convergence? Our interval of convergence would be from negative 4 to 4. Any x value in between there, if we were to plug it in, that would give us something that converges. Any other x value would make that a divergent series. All right, let's do the same thing here. Let's find the interval of convergence. So our u sub n is 7x to the n over 2n factorial. U sub n plus 1 has us take our n and replace it with n plus 1. So we have to be careful on bottom because we're replacing n with n plus 1. We're not just simply adding 1 here. So we're adding 1 directly to the n, not to 2 times n. So that makes u to the n plus 1, 7x to the n plus 1 on top. On bottom, 2n plus 2 factorial. Because if we add 1 to that n, the n and the 1 both get doubled. So we're going to take the limit of the absolute value of u to the n plus 1 divided by u to the n and we want to find out when is that less than 1. For what x values is that less than 1? So since we're dividing by a fraction, we can multiply by the reciprocals. So 7x to the n plus 1 over 2n plus 2 factorial times 2n factorial over 7x to the n. When is that less than 1? So with the 7x to the n plus 1, we can rewrite that as 7x to the n times 7x to the first. That will make that 7x to the n and that 7x to the n cancel. With the factorials, remember how we reduce factorials. We take the larger and we list the factors until we get down to the same point we are on top. So 2n plus 2, the 1 less factor would be 1 less than that, so 2n plus 1. 1 less than that is 2n, and all of the other factors will match. So the 2n factorial reduces. So we're left with a limit is n goes to infinity of the absolute value of 7x over 2n plus 2 times 2n plus 1. So we want to find out, well, for what x's is that less than 1? For what x's is that less than 1? Well, look what happens. If we let n go to infinity, the denominator goes to infinity, So no matter how big x is, if the numerator is a constant and the denominator goes to infinity, then that limit is 0. Well, 0 is always less than 1. Say that again. When we take the limit of this as n goes to infinity, since the numerator is considered a constant and the denominator has n, since that denominator is going to infinity, this fraction is going to 0. That means x can be everything from negative infinity to positive infinity. Any number you pick, when we plug it in for x, that limit is 0. That's always less than 1. So it converges always. That's the interval of convergence.